Welcome to our course Kotlin and Android. Before moving ahead, let's understand the purpose of this course. The purpose is to learn and understand the fundamentals of Kotlin and use Kotlin to develop Android applications using Android Studio 3.0. So, what is Kotlin? Now, Kotlin is a statically typed programming language for modern multi-platform applications. When I say statically typed, we mean that a language where if the type of a variable is known at compile time, for instance, if you are aware of some of the languages like Java, C, C++, they are all statically typed languages. Now, Kotlin offers type inference as well. Now, it's a capability of the type system to deduce the type of variable. Now, the main advantage here is that all kinds of checking can be done by the compiler, and therefore a lot of trivial bugs are caught at a very early stage. So that's what a statically typed programming language is, and Kotlin is one such language. Now, it is 100% interoperable with Java and Android. One can easily convert Java code to Kotlin using popular IDEs like NetBeans and Android Studio. Using Kotlin, we can build applications for Android browsers as well as building server-side applications. Our primary focus will be on developing Android apps using Kotlin. So why we should be using Kotlin? There are 4 reasons for it. First one, it's concise, safe, interoperable, and tool-friendly. When I say concise, it drastically reduces the amount of boilerplate code. Safe, it avoids entire classes of errors such as null pointer exceptions. Then we have interoperability, that is leveraging existing libraries for the Java virtual machine, Android, as well as the browser. Coming on to tool-friendly, we can choose any Java IDE or build from the command line itself. So, how does a Kotlin program looks? Here's the simplest version that we have. We can include an optional package header. Here I'm saying that package as hello, and then we have package level function which takes an array of string as parameter. So we are saying fun as in function, main, that's the main function, arguments is the name of the variable, and we are specifying the type of the variable by separating it with colon. So arguments colon array string, that means argument variable is type of an array which consists of strings. And then we are going inside that method and saying println, that means print a line, and the line will have hello Kotlin, and the line will say hello Kotlin. And you can see that we have not provided a semicolon. That is basically optional, so even if you have one, you can put it there, but if you don't, it's not required. So that's one more bit of less code to write. So we'll be exploring Kotlin in detail in upcoming lectures. In order to work with Kotlin, we must have JDK installed. Here you can see that I've provided 2 links. The first one is for JDK version 9 and the other one is for JDK 8. I'll be installing Java Development Kit 8 on my system, and here clicking on these links will take you to these pages respectively. So 9, this is the page you need to download based on your operating system. So you can see that for Windows it has provided 64-bit version, and similarly you have different file options for Linux, macOS, and Solaris. So you can download either JDK 9, but I would recommend going with JDK 8 as it's available for 32 as well as 64-bit operating systems. So here you can accept the terms and conditions and accordingly choose whatever version you want to download. For instance, I can go ahead and choose this 32-bit version and click on this to download the program. Once downloaded, you can just click on this executable to begin the installation process and follow the instruction along the way. So once it's downloaded, you can click on this to begin the installation process. Now you click on yes, and here you can click on next. Then let the default setting be there, and you can see that it's going to install at this location C program files x86, which represents 32-bit libraries directory, and then Java JDK 1.8.0_161. You can change it as well, but I would recommend to keep this directory as is. Then click on next, and as you can see, it will install the JDK. And here you are provided with another option of changing the destination folder. If you want to install it in this directory, let it be and click on next. And here you can see it says installing Java. Soon your Java development kit will be installed on your system, and then you'll be all set to work with Kotlin using your favorite IDEs. And that's pretty much it. You have successfully installed JDK on your system. Click on close now. So in the next lecture, we'll be installing IntelliJ, as well as we'll see how we can include support for Kotlin in Visual Studio Code editor as well. A little introduction of Kotlin. Let's see how we can integrate it in Visual Studio Code. There are two extensions available in Visual Studio Marketplace. If you search by Kotlin by clicking on the extension menu option, you'll get this result, Kotlin language. So here's one, Kotlin language support for VS Code. You need to click on install. The other extension that we will be installing is Code Runner. So Code Runner is basically an extension using which you can run code snippets in various languages, and Kotlin is a new addition to that set of languages that it supports. So let's go ahead and search for Kotlin one more time. And here we have Code Runner. So we'll click on install over here. So once it's installed, you can click on the reload option to reload this and make this extension active. These are the features of Code Runner, and here's the usage. To run the code, we can press Ctrl-Alt-N, or we can also press F1 key to run the code. And in order to stop it, you can press F1 again, or you can use the shortcode Ctrl-Alt-M. Now here you can see some examples that are being shown by the Code Runner. And then we have the configuration section available. Now in order to go for the configuration section, we need to first reload this so that it becomes active. Now we have reloaded it. What we need to do now is go to File, then go to Preferences and click on Settings. And here you can see Run Code Configuration. Just click on this, and you can see that for most of the languages, the executor map setting is already provided. So what we'll do is we will directly go ahead, we'll create a Kotlin file over here and we'll try execute it. Okay, let's do that. In order to create a file, we'll go to our Files option, Explorer option, and here we'll create a new file. And the file name will be helloworld.kt. Now kt is the extension for Kotlin. So when we tried running the code, here's what we are getting. It says Kotlin Inc. is not recognized as an internal or external command, operable program or patch file. Simply means that we don't have the Kotlin compiler as of now in our system. So what we need to do is head over and download this compiler. So here's the link where you can find the Kotlin compiler. And you can see this is the zip file that we need to download. Just click on it. So now it's downloaded. Let's go ahead and unzip it. So here's the file. I'll be extracting it inside this directory. And once that's done, the content of Kotlin C directory will be copied over inside this Kotlin C directory, and I'll simply paste it over here and just say continue. So now we have it over here inside our program files. Next, what we need to do is include this path in our path variable. So here I am now inside all control panel items system, and I've clicked on advanced system settings. Here I need to click on the environment variables, and here you need to click on the path variable. Inside system variables, click on edit, and you'll get this whole line. You just need to add a new one. So here I'll click new, and I'll be pasting the path. That's C program files, Kotlin C bin directory. Click on OK now, and click OK over here. Click OK again, and there you go. So now we have the Kotlin compiler set in our path environment variable. So after updating the path system variable, we need to reopen our Visual Studio Code editor, and once you have done that, you can just open up the file, right click, say run code, and there you go. Hello Kotlin. So that's how easy it is to integrate Kotlin with your Visual Studio Code. Now in the next lecture, we'll see how we can work with Kotlin using IntelliJ IDE. In this lecture, we'll see how to install IntelliJ and configure it for Kotlin. So first thing, you need to visit this website, jetbrains.com/idea. Click on download button, and you'll be taken to the download page. Here you have two versions for Windows, and we'll be going with the community version, which has got the support for Kotlin, as you can see over here, Java, Kotlin, Groovy, Scala. Now clicking on download over here, and you're not required to provide this information or subscribe to it. You can simply go ahead and download this. As you can see, it's 367 MB, so it will take a bit of time to download, and once it gets downloaded, we can simply click on it and install it. Once it's downloaded, just click on it, and then you can click on next, and here you can choose the directory where you want to install it. Click next, and here you can create shortcuts as well for 64-bit as well as for 32-bit, and we can also have associations created for Kotlin, and you can then click on next and click install. Here the installation has begun, and soon it will complete as well. Once it gets installed, you can simply select this one, run IntelliJ IDEA Community Edition, click on finish, and here you can click on OK. You just have to accept the terms and conditions, and then click OK over here. You can select any of the themes that are available. Let's go with the default one. Click next to default plugins, click next again, and click here which says start using IntelliJ IDEA. You can click on create new project, and here there are two options actually available. You can see Java with Kotlin JVM, and then we have Kotlin itself which says Kotlin JVM, JavaScript, and multi-platform, which is an experimental mode as of now. Let's go ahead and select Java and say Kotlin JVM. Here you need to have SDK defined. So what we can do is choose where our JDK is installed. So you click new, and in C program files, Java, we have JDK. We'll select JDK 1.8 and select OK, and here you can see the project SDK is now selected, and the library Kotlin Java runtime is also selected by default, and we just need to click next now, and here we can give our project a name. So here we have our Kotlin IntelliJ directory created. Click OK, and this is the name of our project. Click finish now, and you can close this step. Just zoom it a bit. So here we have our project now. These are the libraries, and here's our src directory, and these are the external libraries, the JDK and Kotlin Java runtime, and here you can add a new Kotlin file and give it a name. Let's call it as hello world, and here it's created now, and here you can see that we have created a hello world.kt file, created this function main which contains the argument variable of type array of strings. Then we have this println hello world, and when we execute it or run it from the run menu, you can select run. You can see that this is the output coming up, hello world. You can also explore the Kotlin read evaluate program loop option by going to tools, Kotlin, and then selecting Kotlin REPL. So here you can actually do all sort of things that Kotlin provides you. Like, so I can declare a string over here. I'll run it. You'll see the output coming over here. As you can see, it says Control plus Enter to execute. So I'll be saying 1 plus 2. And let's press Control and Enter. So here it will evaluate to 3. And similarly, I can do other stuff like hello, then concatenate it with another string world, and then again press Control Enter, and there you go. So all these kind of things you can do in Kotlin REPL using IntelliJ IDEA IDE. So that was how to work with Kotlin using IntelliJ IDEA. In this lecture, we'll see how we can use Kotlin in Android Studio. Now, Android Studio 3.0 comes with Kotlin, but if you're using an earlier version of Android Studio, you can still go ahead and use Kotlin by installing the Kotlin plugin. So here's what we'll be doing. We'll be going to Configure, we'll choose Plugins from here, and next the window pops up. Over here we'll be installing the JetBrains plugin, and as you can see over here it says install JetBrains plugin. Just click on it, and then you need to select Kotlin over here, click on install, and once this gets downloaded and installed, you'll need to restart the IDE or Android Studio. And here you can see that it says restart Android Studio. Let's go ahead and do that. We'll click on restart. Now you can click on start a new Android Studio project. And here you can see that I've provided the application name as Kotlin Android Demo, the company domain over here, and then the project location. Now click on next. And here you can choose the minimum SDK version. Let's go ahead and choose Lollipop over here, and now go ahead and click on next. So here you can see the Android SDK is installed at this location. See Android SDK, and it has downloaded all the necessary packages or components. Click next. Go ahead and select the default one, empty activity. Click on next. And by default it gives a name called main activity, so let it be main activity only, and then you can click on finish. So our project is created. Now in the next lecture we'll see how we can convert the Java code to Kotlin, and we'll also see how we can configure Kotlin in our project. In this lecture we'll take a look at how we can convert the Java code that we have over here to Kotlin. Now in order to do this conversion, we have a couple of options, like going to help and then clicking on this find action, and once you have the action pop-up coming up, you can simply type over here convert Java file to Kotlin. As you can see over here, the next step to do the same thing is going to the code option. So here you click on code, and then the last option over here, convert Java file to Kotlin file. If you click on this, the whole code will get converted to Kotlin. You can see the file extension also changed to .kt, and this is the Kotlin version of the same Java code that we had earlier. So this way you can easily convert your Java code to Kotlin. The next thing that we need to do is configure our Kotlin project. So to configure it, we'll be going to tools, then we'll select Kotlin, and here you can see configure Kotlin in project. So click on that, and we will select this option, all modules containing Kotlin files. Kotlin compiler and runtime version is selected over here. Click on OK. You can see that the Gradle files have been updated now, so we'll click on sync now. You can see over here the Gradle download is under progress, and once it's done, we'll be able to work on our project. Now the Kotlin runtime is pretty small, so the APK that gets generated is marginally larger in size, and the Kotlin compiler basically produces bytecode, which is exactly what Java produces. So there is really no difference in terms of look and feel of Kotlin application versus those written in Java language. So that was about configuring your Android with Kotlin, and from next lecture onward we'll be covering the basics or the fundamentals of Kotlin, and then once we are through that we'll start working with the Android Studio and Kotlin. This lecture will be starting with strings, arrays, booleans, characters, and numbers. These are the basic types that Kotlin supports. So let's go ahead and explore each one of them, starting with strings. So here I have a function called main, and it is basically having one parameter called arguments, which is of type array of strings. Here inside that function I have created a variable val s for string, which is containing this hello world. Now, so strings are immutable, and elements of a string are basically characters that can be accessed by the indexing operations. So you can say that a string is basically an array of characters, and if I have to loop through them, which we will be exploring when we'll be covering loops in Kotlin. And talking about strings, we must know about string literals. Here in Kotlin we have two types of string literals: scaped strings that may have scaped characters in them, and raw strings that can contain new lines and some arbitrary text. So if I have to make this as an scaped literal, string literal, I can say \n, and scaping, as you can see, is done with a \. And if you are talking about raw string, so there we make use of triple quotes. So I can have another variable over here like val t equals triple quote, and then I can say line 1, line 2, and then close it with triple quotes. So that's the other string literal, and you can see the output over here as well, line 1, line 2. Okay, now let's talk about string templates. So whenever you have some expressions or variables that you want to evaluate along with a string of message, you can make use of string templates. So strings may contain template expressions, which are basically pieces of code that are evaluated, and the results are then concatenated into this string. So I can say in this way, we have, let's say, a variable I equals 8, and here's another one, let's call it as result equal to I equals $i, and let's close this. So now if I go ahead and print this one, the expression that we have stored over here in a result variable will be I equals 8. There we have it. Similarly, we can also have arbitrary expressions in curly braces as well. So another example of a string template would be finding the length of a given string. So we already have this s over here which says hello world. So what I'll do is I'll be using another variable, and let's call it as len equal to $s. So this is the variable which I'm referring to when I'm saying $s, and here dot length is inside the curly brackets, I'll say s dot length. And if I just go ahead and print this, you can see it says hello world, then a line break is there because we have this escape character \n, and dot length is 12. So the new line character is also counted. And there we have it, string templates. We'll be continuing this lecture, and in the next one we'll be covering arrays in Kotlin. In this lecture we'll be covering three things. First, how we can define packages, defining variables, and then comments. So let's start with defining packages. So here in our Hello World example, if I have to include a package, then the package specification should be mentioned at the top of the source file. So in this file, we can have the first line as the package itself. So here we'll say package, and then the package name will come like this, SkillBakery dot, let's call it as demo. So this will be the package, and then we can have our code. If you have to import some Java libraries, you can also do that after the package. So we can have something of this sort, import, and then java.util.star or asterisk. So that way we can have our packages defined. Now let's go ahead and see how we can define a variable. Okay, so here we have our main function. Inside this function we can have some variables declared. For instance, if I have to declare an integer variable, I'll say var and num equals 5. Now here the value 5 will be inferred as an integer, and the data type of the variable num will become integer. That's something which Kotlin does automatically. If I have to specifically mention that the data type needs to be integer, I can say val and count int. So here the variable count is defined as integer, and then I can assign it a value in this way. Now if I have to do all this in one line, I'll say val step, that is the name of the variable, colon, and let's specify the data type integer, and after that give it the value. So I'll say 4. So in one line we are declaring the variable as well as initializing it. So step will now have the value 4 and its data type is integer. And when we define a variable where its type is inferred, that variable is mutable as well. So if I say var num equals 5, I can say num plus equal to 1. So here we'll have the value incremented by 1. And if I have to take a look at it, let's go ahead and do that. So I'll say println, and here I'll say num. Let's run it. You can see that we are also getting some warnings that the variable are not used at all. And here you can see the output 6. Now there are some other types of variable as well. We can call them as top level variables. So if a variable is defined outside this main function block or outside a function, for instance val pi equals 3.14, in that case this value of pi can be used inside the function main as well. So I can say println pi, close it, and save this. Let's go ahead and execute it. And there we have it, 3.14 being accessed inside the main function. Now let's go ahead and take a look at comments. Now comments are exactly same as we have it in Java. So if you have to go for a single line comment, you can say it in this way, 2 forward slashes. And if you want to comment a block of code, you can go with / asterisk and asterisk /. So these are the three things that we have covered in this lecture. First being including packages and importing libraries. Second was declaring and initializing variables. And third one was working with comments. In this lecture, we'll be taking a look at string templates in Kotlin, and we'll also see how we can define functions. We'll be actually covering a couple of function types. Functions which accepts parameter and returns something. Functions which accepts parameter but do not return anything. So all those sort of things, and we'll be also covering string templates in functions as well. So let's go ahead and start with string templates. So here we have a variable called num, and we are incrementing its value from 5 to 6 by adding 1 to it. Now if I have to print this in a meaningful way, simply I can do this println num. But if I have to say that the value of variable num is so and so, kind of a message, in that case I can go with string templates. So let's say val result equals, and inside double quotes I can say value of num is, and then I'll use dollar symbol, and then I'll say num. So now I have a string template defined, and if I go ahead and print result instead of num, the output, as you can see, comes up as value of num is 6. So that's one way of using a string template. We can also have a so-called complex version of it. So you can actually perform some string operations like replace. So if I take this var result from here and put it over here, print it in this way. So now the value will come as 5, and here I can declare another variable. Let's call it val final result equal to, and inside the double quotes I'll say dollar. I'll make use of the earlier variable result. So in the curly bracket I'll make use of the variable result over here, and then I can use replace a method on that variable, and replace is with was. So you can see that I'm using a replace method on the variable result in the string template itself. So it says result.replace is with was, now it is num, and here I'll again print this result, final result. Let's rerun it, and there you can see the result is appearing over here. Value of num is 5. Then for final result it says value of num was 5. So basically this string is used over here as result, and then I just replaced is with was. So result was evaluated in that way. Result value of num is 5, and now it is num is coming up from here. So this is $num coming up over here. Earlier there was just the string replacement, so whatever value it got evaluated to was printed over here, and is was replaced with was. So that's how we can work with string templates. Now let's go ahead and explore functions. We have already seen one example of the main function itself, where we are actually accepting parameter of type string, array of strings basically. Here I'll be creating one more function. So I can say function sum, and let's have two numbers which we will add. So we can say x as integer and y as integer. So these are the two variables, and the output or the return of this function is an integer. So basically the sum of two numbers will be returned. So I'll say return x plus y. So this is one function which accepts two parameters of type integer and returns an integer value. Similarly, I can have another function which might not return anything at all. So we'll be actually making use of a string template in that. For instance, I can say a function, let's say display sum, and here I can say same numbers, x as integer and then y as integer, and the return type, you can have something but it's not required, so we can simply omit it. And inside this I will say println sum of $x and $y is dollar, then curly bracket x plus y. And there you go. So this will simply display the sum of two numbers. It's not going to return anything. Now there's one more thing that we can do to a function. By creating a function expression, and the return type is basically inferred from the function. So I can simply write this function sum in this way as well. Function sum and x as integer, y as integer, and then the output of this as x plus y. So basically this is a shorthand notation of the same function which we have defined over here. So it comes handy when you have fewer lines of code, like over here we were just returning one, but if you have a multiple statement block in a function, then obviously you should go with this approach. Now let's go ahead and use this function display sum in our main function. So I'll call it over here display sum, and let's pass two numbers to it, 5 and 4, and see the output of it. So you can see it says there's some error because we have two definitions. So I'll remove one, and here you can see the result is coming up as sum of 5 and 4 is 9. So that's how you can create a function in Kotlin and make use of it in your programs. In this lecture, we'll be covering Booleans and character data types. So let's start with Booleans. Boolean data type has got two values. That is, it's either going to be true or false. And Booleans are boxed as well if a nullable reference is needed. We can perform various operations on Booleans like negation, conjunction, and lazy conjunction. In other words, we can have and, or, and not operations on Boolean data types. So if I have to define a variable which is of type Boolean, I can say val is true colon. So we'll write val is true as Boolean data type, and then we are assigning the value true to it. And here you can see when we are printing this value, println is true, it's returning true. If I just use the negation operation over here and then try to print it out, you can see it says false. So that way you can play with the Boolean data type. Next we have characters. Now characters are represented by the data type char. So if I say char, this is the data type, and we can define a variable of char data type as well, char. And whenever you are creating a character, basically you enclose them with single quotes. So here I can say char equals C, and there are a couple of escape sequences that are available, like tab, backslash, new line, carriage return, single quotes, double quotes, backslash, and dollar. So now I can just go ahead and say println and char over here, save this, let's run it. and here's the output. Just one more thing, that is characters are boxed when a nullable reference is needed. In the next lecture, we'll be taking a look at numbers, where we'll be covering all sorts of numbers data type that we have, like double, float, long, int, short, byte. So that will be coming up in the next lecture. In this lecture, we'll be taking a look at the numbers data type. So we have double, float, long, integer, short, and byte data types. And double is of 64-bit, float is 32-bit, long is 64-bit, integer or int is 32 bits, short is 16, and byte is 8 bits. Next we have literal constants. So if you are having long, you can denote that number with L by appending the literal L to the number. So here we have 1, 2, 3 L, that means it's a long. Then we have float. So to differentiate between decimal and float, we can have float 123.5 F. So appending F makes it float. Then we also have one convenience when we are working with numbers in Kotlin, and that is providing underscores. So it brings readability to the numeric value that we have. For instance, over here we are saying 1 million equals 1, then underscore 000 underscore 000. So you can have underscores in numeric literals, and that way it makes the long numbers more readable. Now in the next one, we will be starting with packages and imports, and then we'll be covering control flow. In this lecture, we'll be exploring packages and imports. So any source file that we have can start with a package declaration. Now a package basically consists of classes and functions, and some of the packages that are available by default in every Kotlin file are Kotlin annotation, collections, comparisons, IO, ranges, sequences, and text. So these are the default imports, you can say. And based on the environment that we are targeting, for instance, if we are targeting Java virtual machine, then we have java.lang and kotlin.jvm packages available. So if we have to import, so if we have to include a package, we can just say package foo.bar. So for instance, over here you can see that we had this package skillbakery.demo. Now this is the package for this particular file. So the main file that we have, so the main function that we have is now inside this package. So that's what package basically wraps up everything. That's classes and functions, everything. So if I have to say this main function, it is skillbakery.demo.main. That way we can access this function. Now coming on to imports, as we have over here, imports java.util. So when we say import java.util, or for instance we say foo.bar, so bar will now be accessible without any qualification. Similarly, if you just want to include everything that the foo package has to offer, we can simply say import foo.star. So everything in foo becomes accessible. Now if there is a name clash, so let's say two packages are there with same name, in that case you can just name one as an alias. For instance, if we have bar classes in foo.bar and bar.bar, in that case we can just say bar.bar as bbar. So bbar will now point to bar.bar. That way you can resolve these conflicts. Apart from including classes, we can also include or import top level functions using the import keyword and properties, as well as enum constants. So that was packages and imports. In the next lecture, we'll be starting with control flow. In this lecture, we'll be taking a look at control flow statements in Kotlin. The first one that we'll be looking at is the if statement, then we'll see if else, and we'll also cover when, for, and while. Now when is basically a replacement for switch. So instead of switch we have when in Kotlin. So let's go ahead and explore these. So here you can see that I've declared a variable called num with the value 5, and here I'm making use of the if statement, which is trying to compare whether the num is greater than 4 or not. If it is, then we'll be printing that number. Now here in Kotlin, if is basically an expression, that is, it returns a value. Therefore, there is no ternary operator that is we had in other languages where you specify a condition, then a question mark, and after that true or false value. That is not the case in Kotlin. So how do we achieve that kind of expression? In Kotlin, we can do that by having the statement in this way. If num is greater than, let's say, 4, then we are printing the value num itself, else we'll be printing anything other than that. Please note that in this case, when you are treating the if as an expression, then the else is mandatory. So you cannot remove else in this case. So that is a requirement. Now, the other flavor of if is with the else block. So if the statement is true, we are printing one thing. In case the statement is not true, then the else block gets executed. Now coming on to the when statement, it's a replacement of switch. So in Kotlin we don't get the switch flavor over here, we have when. So when, then you are passing the condition. Over here I'm saying num. Now we know that num is set to 5. So this block will not be executed. This block also will not be executed. The else block will be executed. So this is something like default in switch. So if nothing matches, the else block gets executed. Okay, and whatever expression matches, that becomes the value of this whole when block. So over here, this is what will be printed. Now coming on to loops, we have for loop. So remember we had arrays in Kotlin, we discussed about it, and here we will be actually looping through all of them. So I've created a numbers array, and here we have got a couple of flavors of for statement. The first one is for item in numbers. You can simply print that number. You can also specify the data type of that particular array. So if you are having an integer array, you can simply say for item of type integer in numbers, and then you're printing that out. You can also go ahead with the index thing. So here you can see I'm looping through index position. So I'm saying for I in numbers dot indices. So let's say we have 4 items in our array. Index position will be 0, 1, 2, and 3. So it will loop through that, and for each of the index position, whatever value we are having in our numbers array, that will be printed. Then we have index and value. So if you want to say at index position so and so, this is the value. You can do that as well using this flavor of the for statement. So you can see we are passing index comma value and then the numbers dot with index method. So using that we will be able to access the index as well as the value. That's what we are passing over here. And finally we have while loop, and here you can see while num is greater than 0, we are decrementing the value, and if I wish to print it, that also I can do. Print num. There we go. So that's how we work with for, while, if condition, when statements in Kotlin. So let's go ahead and execute this program to see the results. So there we are, the output is coming up. The last one, which you're seeing 5, 4, 3, 2, 1, is from the while loop. Then these that you're seeing over here, from here, are using the index and value flavor of the for loop. And here that you're seeing num is neither 1 nor 2, it is 5. This is actually coming from the when statement. Then all these random numbers that you're seeing, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, these are actually the values being printed for 3 different flavors of for that we discussed. So all of them are actually printing the same value, 1, 2, 3, 4, 1, 2, 3, 4, and using indices as well, 1, 2, 3, 4. So That was all about control flow statements in Kotlin. Covering arrays in Kotlin. So arrays in Kotlin are represented by the array class. We have two ways of creating arrays. First one using the array class, and the other one is using the library function called array_of. So let's first of all check how we can create an array function. We can create an array using the array class. So here we have a variable, let's call it as array, and we'll be making use of the array constructor, and here you can define the size of that array, and then you can also pass one parameter which will be initializing those index positions. So I can say it in this way, where I'm initializing each index position with the index value itself. So for index position 0, the value will be 0, as you can see from the output over here, and if I just change it to 1 and save it and run it again, you can see the output is coming up over here as 1. So that's one way of creating an array. The other way is to make use of the array function. Now this is what you will come across most of the time when you are working with arrays using the array_of function. So if I have to create an array of numbers, let's say val num equal to array of, the O will be caps, and here you can just specify the numbers like 1, 2, 3, 4, and this is going to create an array of 4 integers that are 1, 2, 3, and 4. So if I go ahead and print over here num and let's say 2, this time this will return me 3 over here, and there you can see the output is coming as 3. Now we also get a couple of functions on arrays like get, set, and size. So here I can print the size of the array. You can see it's coming as 4, so that's the total number of items in this num array. So num.size gives us that, and if I have to set the value of any index position, I can do that. So I can either use index like this, num of 2 equal to 10, and I can also make use of the set function, so num.set, and here I need to pass index position. So the index position let's consider as 0, and then the value at that index position, let's say 15. So using either of these two ways you can set it, and if I have to print it again, the one way of printing it is using the index position over here, and the other one is using the get method. So I'll say num.get, and then I'll pass the index position, let's say 0 over here, and you can see the output coming as 15 because that's what we set at index position 0. So the value is coming as 15, and now if I say at index position 2, you can see the value is coming as 10 over here in the results window. Now there's a difference between arrays in Java and arrays in Kotlin. That is, arrays in Kotlin are invariant. This means that Kotlin does not let us assign an array of a string, like over here we have in our main function, to an array of any, which prevents basically a possible runtime failure. And Kotlin also has specialized classes which represents arrays of primitive types without boxing overhead, like we can have byte arrays, int arrays, short arrays, and so on. Now these classes have no inheritance relation to the array class, but they have the same set of methods and properties, so you'll get all those set, get, size methods which you get in an array class. So here I can go ahead and create an integer array altogether in this way. So let's say val y equal to val y as int array, and int array of. So you can see that earlier we were just using array of. Now if I have to go with integer array, I am saying int array of. Similarly, if I have to create a byte array, I will say byte array of, short array of, and so on. So here we have, let's say, numbers 1, 2, 5, and that's pretty much it. Now you can print them in this way. So let's say at index position 1, and the array is over here y, so we can print them over here, and you can see the output is coming as 2 over here. So there was arrays in Kotlin. In the next lecture we'll be covering booleans and character data types. In this lecture we'll be taking a look at structural jump expressions in Kotlin. There are 3 actually: return, break, and continue. So let's go ahead and explore all of them in detail. So we'll be starting with break and continue. Now to explore these, the best way is using loops. So already in our previous examples we covered loops, and in this one we'll be making use of them to explore break and continue. Now any expression in Kotlin may be marked with a label. Labels have the form of an identifier followed by @sign. So if I have to label this for loop, I'll say loop and then @symbol. So this is now labeled as loop, and once we have marked an expression using labels, we can qualify a break or continue with the label. So I can say that if item equals 3, in that case I want to break this loop, so break @loop. So you can see how this is working. What we are doing over here is, first of all, we are marking this for loop as loop. That's the label we have given, and then if the item is equal to 3, we are breaking it, so it's going back to this position. You can relate it with goto statement in previous programming languages. So here if I now run this one, so here you can see that for this particular loop the output is coming as 1 and 2, and then it's breaking. So whenever we are making use of a break statement, it just jumps to the execution point right after the loop marked with that label. So it goes back to this point and breaks it, and there's the reason why we are only getting 1 and 2 printed over here. Now if I use continue instead of this, let's do that over here itself. If item equals to 2, so I'll be commenting this one now, and here I'll be saying continue @loop. So when we make use of continue, it proceeds to the next iteration of the loop. So here let's print out and see the result. So here it's coming as 1, 3, 4. So when the item was 2, it just skipped that and moved on to the next one. That's 3 and then 4. So that's the difference between break and continue. Break actually exits from the loop itself, whereas continue just skips that particular condition and moves on with the next item in the loop. Then we have return statement. So the return statement or expression basically returns from the nearest enclosing function. So here you can see that we are making use of a list of, and the items are 1, 2, 3, 4, and 5, and for each then we are giving it a label, let A. And if the item is equal to 3, it's returning from there. So let's see the output now. And here you can see that it's behaving like a continuous statement when we are making use of the label over here. So when the condition is 3, it's going to this point and the loop is continuing. So 3 is skipped and then 4 and 5 is printed. So that's how we can make use of break, continue, and return expressions in Kotlin. In the next set of lectures, we'll be covering classes, constructors, class members, inheritance, how we can override properties, and what are abstract classes. So all these things we'll be covering in next set of lectures. We'll be starting with classes. So here I've opened Visual Studio Code, and you can see that I've created a file called classes.kt, and in order to create a class, all we need to do is just say class and then the name of the class. Let's say student, and you open it and close it in this way. So that's how you create a class in Kotlin. Now the class declaration, as mentioned, consists the class name, and it can also consist of the primary constructor. So the constructor is actually optional, as you can see from this example. I can have another version of it in this way, class student, and then I can say constructor, and here I can say the default parameter like first name as a string, and I can open and close it in this way. So that's the primary constructor that we have for a class. We can have only one primary constructor and more than one secondary constructors. And you can see that the primary constructor is actually part of the class header itself. It just goes after the class name. So we have class name student, and then the constructor, primary constructor. The parameter that we are passing is actually optional, so you can have a constructor which does not take anything at all. So, and when you have a primary constructor, it cannot contain any code. So for instance, over here, if I have to write some code, I'll be actually doing that inside an init block or initializer block, I can say. So I'll have it in this way, init, and inside this init block I can have my code. So for instance, I can say println first name. That's the parameter that we'll be receiving in the constructor. So that we can have inside the initializer block. And here in the class declaration we can have properties. So I can define a property, but not any functional piece of code directly inside the class when we have primary constructor. So I can say val unique key, and this can be some value like 1 2 3 plus the first name. So this parameter that we are having for primary constructor can be used with properties and can also be used inside the initializer blocks. So that was how we can create classes, how we can create primary constructors and make use of the parameters that we are passing in the primary constructor. In the next one, we'll also see how we can pass more than one parameter to the primary constructor and make use of them in our class code. So in the previous lecture, we talked about classes and primary constructor. In this one, we'll see how we can have more parameters passed to the primary constructor, and then we will explore secondary constructor. So if you want to have a primary constructor which contains more than one parameter, all you can do is specify them in this order. Like you have first name over here, then you can define another variable, let's call it as last name, and its data type as a string, and so on and so forth. You can carry on including various parameters that you want in your primary constructor. Now let's take a look at secondary constructor. Now in order to create a secondary constructor, the syntax of it becomes a bit different. So let's consider a class, and let's call it as a person class. So this person class, if I'll have to declare a constructor over here as secondary, I'll have constructor keyword, and this constructor keyword will have a reference to its parent. Now the parent is person class, and in order to refer to the parent class, we will make use of this keyword. So here I can say parent.children.add, and then this. Now let's consider a scenario where we have a parent class which is also having a primary constructor. So here we have our student class which is having a primary constructor. So let's take that as an example over here. And now say that we also have a secondary constructor in this. So each secondary constructor that we will be having needs to delegate to the primary constructor either directly or indirectly. When I say indirectly, it means through another secondary constructor. Now that becomes a bit difficult to understand, but we'll take one step at a time. So delegation to another constructor of the same class is done using this keyword. So here you can see we have our student class, constructor, first name, string. Now here let's delete this for now and let's have a secondary constructor. And now this constructor will have the first name, and then it is also going to refer to the parent student. And here the delegation is this and then first name over here. And inside this we can say parent dot children dot add, and we'll make use of this keyword. Now let's go ahead and see how we can create an instance of a class. So if we have to do that, it's pretty easy in Kotlin. We'll use val as the variable declaration keyword, and then over here I'll say, let's say person. So I'll say person equal to person. And if I have a constructor, a primary constructor associated, I can simply say, for instance, over here we have student. So I'll say val student equal to student, and here specify a name like John. So that's how easy it is to create a class and instantiate it and create an object of that class. Now, as we mentioned earlier, we'll be covering a bit more about classes. So a class can have constructors and initializer blocks, which we have already explored. Here you can see the initializer block we learned about in the previous lecture. Now the classes can also contain functions, properties, and object declarations. So we'll be exploring functions and all when we'll be discussing inheritance in the next lecture. In this lecture, we'll be exploring inheritance in Kotlin. We'll be understanding how inheritance works in Kotlin, and we'll be exploring a couple of inheritance related functionality like overriding methods and properties. So we'll be starting with creating a base class. Here you can see that we have a base class called person. Now this person has a constructor which is expecting name of data type string. Now you'll notice a special keyword over here called open. If you're not making a class open, then you cannot treat it as a base class. So for inheritance to work, it is essential to have the open keyword. Now once you prefix this keyword, this can be used as a base class. So here we are creating another class called student, and you will see that we are having name and roll number as parameters. Now name is obviously part of the person class and roll number is exclusive to student. Here we are saying that it is deriving from the person base class, and person is expecting a name. Over here in the main function, we have created an instance of the student class. We have provided name as John and roll number as 1, and these two lines are simply accessing the name and roll property and printing them out. The third line is actually accessing the info method that is part of the person class, and here it should read a person called whatever name will be passing, which is a student with roll number, and then the roll number will appear over here. So let's save this file and execute it Here you can see the output coming as John1, and then it says a person called John, which is a student with roll number 1. So you can see that we are able to initialize the person class using the student class constructor, and then we are able to access the method defined in the person class using the student class instance. Now if you want to override this function info, you'll again have to mark it as open. So any class or method or property which you want to override must have this keyword prefixed. Now that we have mentioned that this is going to be overridden, if you not provide open over here, then this function will be marked as final and you will not be able to override it. So to allow overriding, you must have the open keyword over here. Now in order to override the method in the derived class, you must start it with the override, then the function keyword, name of the function, and its implementation. So now if I save this and run it, now you can see the difference. A student called John, which is a student with roll number 1, is appearing. Similarly, you can override a property as well. Now one more thing I would like to share here, and that is any class that you create in Kotlin is basically inherited from a base class called any. So all classes in Kotlin have a common superclass and it's known as any. So that was pretty much inheritance in a nutshell, which we have covered over here. Now in the next lecture we'll be exploring abstract classes, and then we will be taking it from there. In this lecture we'll be exploring abstract classes in Kotlin. Now in Kotlin, a class and some of its members may be declared as abstract. Now an abstract member does not have an implementation in its class, and all the members of the abstract class, which includes functions and properties, are by default treated as open. So here you can see that we have defined a class called student as abstract, and this one is having function info defined as abstract as well, and that is why we do not have an implementation of it over here inside the abstract class, whereas this one needs to have an implementation. So it's just not doing anything but is a function. Over here, this one, when it will be implemented in other class, at that point of time this will require its implementation. So that's all about abstract classes in Kotlin. In the next lecture we'll be taking a look at properties and fields. In this lecture we'll be taking a look at properties and fields in Kotlin. So any class in Kotlin can have properties. Now there are two kinds of properties that we can have in a class. One which is mutable, and they are defined using the keyword var and then the name of the property, after that colon symbol, and then the data type. You need to either make them abstract or initialize them then and there. So for instance over here I am saying name as a string data type with the empty value. Similarly city as a string data type with empty value again. You can also directly define a variable in this way, where you are just assigning a value to it, and based on the type of value that you are assigning, its data type will be determined. For instance here roll will be integer type. Now the other kind of property that we can define is read-only property, and they are defined using the keyword val. So if I say val type equal to student, that means I cannot reassign any other value to this variable type. You'll also notice that syntax highlighter tools also differentiate this from the mutable properties. So here you can see it's highlighted in blue color. Now if I try assigning some value to it, as you can see over here, I'm trying to assign teacher to student.type. What it says is val cannot be reassigned. So now if I create an instance of this and assign values to each one of these properties, name, city and role, I'll be commenting out the type over here. So name as John, city as NY and role as 5. So here these are treated as setters. Then the same student.name, city, role and type, when accessed in this fashion, in this manner, then these are treated as getters. So now let's save this and rerun this one more time. And finally you'll see the options over here, John, NY5 and student. So that was properties in Kotlin. In the next lecture we'll be taking a look at interfaces. In this lecture we'll be taking a look at interfaces in Kotlin. So basically, by definition, interface is basically a contract, and whosoever is implementing that contract should abide by the rules. Now interfaces can have abstract class members, which can be a combination of both methods and properties, and they can also have fully defined function definitions as well. Now a class can implement more than one interface. So over here, in order to define an interface, all we need to do is type interface and then the name of the interface. For instance, if I'm trying to create an interface called person, and that interface can have an abstract function called speak. Now here I can create a class, let's call it as student, and this can implement the person interface. You can see the syntax for implementing an interface is class name colon name of the interface, and then inside that you will have to override the function which is mentioned in the interface. So that's the contract. When you are implementing this interface, you need to have a definition for this method or function. So here we have defined that. Now let's create a function, main function, where we can call this, and we'll be doing now student.speak. So if I run this one, you'll see the output coming over here as hello. So we have implemented the person interface in student class by overriding the function speak. Now similarly, we can have properties as well. So if I go ahead and say var name as a string, and then I'll have to define it over here as override name string and initialize it as a blank or empty. Now here I can go ahead and say student dot name is equal to Johnny, and finally I can print that over here. A typo is there, override var name string, and now let's run this, and there you go, the output is coming as hello and the name of the student is Johnny. Now apart from this, we can also create methods which can accept interfaces or the classes which implement those interfaces. In order to explain this, let me create a function enable speak, and here you can see we are passing an object of this interface person, and we are calling this method speak because we know that this interface is having one method with this name. So person.speak will actually call that. Now here, instead of calling student.speak, I'll be commenting this out, and instead of that I'll be passing the student object. Now student object that we see is an instance of the student class, which actually implements the person interface. So by that rule we can pass that thing over here inside this method. Now if I call this, you'll see the exact response hello coming out, and there you go, the output remains exactly the same. Now as we mentioned that a class can implement more than one interface. In that case you just need to separate it by a comma and name of the new interface. For instance, if I'm saying human, but there's a scenario. Consider that both of these interfaces contain same method names. Now in that case you'll have to define those methods in these interfaces. So instead of being abstract, they need to have a definition of their own. So over here, like fun speak will actually be implemented. Okay, and here it will have a definition like println hello, I am a person, so to say. Similarly, for another interface, let's create that as well by copying this person class and putting it over here, making it as human, removing the variable name, keeping this, and here I'll say human. Now in that case you can see now that student is actually implementing person as well as human interfaces. And here, instead of saying println, what I'll be doing is I'll be calling super, and then using the diamond method I'll pass the name of the interface dot speak. So this way I can call specific interfaces methods. And there's no need to have semicolon. Now that way, if I now print this one, you can see that it says hello, I am a person, hello, I am a human, and then the name of the student. So that way, if you are having similar function names, you can use this syntax to avoid the conflict. So that was all about interfaces in Kotlin. We'll be taking a look at anonymous interface implementations in Kotlin. Anonymous interface implementations are basically used as a concept of callback methods in Kotlin to react to various events. So here in Kotlin, in order to implement the anonymous interface, we'll be taking an example of event handlers. So here I have created one class called clickEvent, and it's just giving the X and Y coordinate positions where exactly the click has happened. Now I'll be creating one interface for this, and as you can see it has got this method called onClick, and the object that we are passing is of type clickEvent, which is this class. Once you have the interface defined, we'll be creating a class. Let's call it as stateful class. And this one is actually having a primary constructor, which is taking the click listener interface object over here as an argument. Here I'll be creating another variable. Let's call it private var, and I'll be starting it with underscore click listener, and this click listener will be of type interface that we have over here, click listener. Now in Kotlin, if you are expecting the parameter to be nullable, you can append question mark symbol equal to listener in this way. Now let's define the function click me over here, and this will take two parameters, x and y, and inside this I'll be taking this click listener question mark dot onClick and inside that I'll be calling the click event class with these two parameters x and y that we have passed over here in this function. Now that's done, let's go ahead and create our main function. So we'll say main args array of string, and inside this I'll be making use of the anonymous interface. So let's have a variable stateful equal to stateful class that we have over here, and here we'll be using a keyword called object. Now this object will be of type interface click listener. Okay, and here inside this we'll be actually overriding the function on click, this function that this interface has. So on click, and then obviously we will have the same parameters like this event click event. Inside that we'll implement it by printing the x and y coordinates. So we'll do it in this way. Once that's done, we'll make use of the stateful dot click me method. So here we have click me. So we have created an instance of the stateful class and then stateful dot click me, and inside this we'll be passing, let's say 10,20 as x and y. Let's save this and run it, and here you can see the output is coming as click at 10,20, the positions x and y that we have specified. So here you can see the object that we have is basically anonymous because you don't have to create it as a named variable. Instead, you define the object at the same time as you pass it to a function that requires that object as an argument. Now the function is typically a member of a stateful class that holds onto that reference and then can call the function whenever it's needed. So that's how we are implementing anonymous interface in Kotlin. In this lecture we'll be talking about lambdas. Lambdas basically helps us in writing concise code. So here we'll be first of all taking a look at the syntax. As you can see over here, we have the type which the expression is supposed to operate on, and then it will return a value. For instance, over here in this example, what we are doing is we are creating an immutable function which is using the lambda expression. As you can see inside this curly braces we have the input and then the business logic over here. So it is basically divided into two parts. As you can see, the left one is the input section and the right one is the business logic. So here we are trying to find out whether a given number is even or not. So if it's even, it will return true. If it's not, it will return false. So the output is of type Boolean, but the input that it's taking is of type integer. So the output data type is never mentioned in the lambda expression. It's automatically assumed by Kotlin. So now if I save this and run it, as you can see, it is returning true. Now if I go ahead and change this to 3 and save this and rerun it, the output is coming as false. So that's a short example of understanding the lambda expression. In the next lecture we'll see how we can make use of lambdas in our function. So we'll be passing lambda expressions in functions as parameters. In this lecture we'll be taking a look at how we can pass functions as lambda expressions. But before doing that, I would like to highlight one more way of invoking. So in our previous lecture we saw how we can make a call to the result immutable function that we have created, and in order to do the same, there is one more way of doing it, and that is by making use of the invoke method. So you call result.invoke and then pass the parameter that we have, and it's going to output exactly the same result which it was doing with this. So it's just another way of calling it. Now the other example that you're seeing over here is basically passing multiple parameters. So in the previous one we were just having the integer value over here. Now here you can see we have two parameters, one called user, which is of data type string, and the other one is age, which is of type integer. And here we are printing them as hello user, your age is this. And to call it, we are writing it in this way, greet. Then we are passing the parameters John, and the age over here, semicolon is not required, so let's remove that. And now we will be running it. So here you can see the false that is shown over here is coming from println result.invoke, and the last line that you're reading, hello John, your age is 30, that is coming from the greet method that we have created. So basically a Lambda expression lets you call functions as objects, and you can pass parameters using a simplified syntax and avoid creating anonymous objects. Let me give you another example over here. We'll be creating an array, let's see over here, as solid, liquid and gas matter states, and if I have to sort this one, I'll be doing it as val sorted equal to states dot sorted by, and inside this I can write it in this way, state, and then you can see the same set of parameters being passed. So this is the parameter that we are passing. Similarly, state over here is the parameter, and then we will be having the logic as state dot length. So now this will be curly bracket in this way. Now it's going to sort this array on the basis of the length of each item that we have in that array. So now if I run this one, so this one is doing in ascending order, so from minimum to maximum, it's going as gas, solid and liquid. And now if I want to further shorten it, that is, if you are just having one parameter in the method, you can further get rid of this statement. So if I comment this one and put it like this, instead of state and all, I will just say over here as IT, that is it. And now if I run this, you can see that the output still remains the same. Further, I can call other methods as well on this. For instance, if I have to filter it on the basis of, let's say, starts with S, and if I have to ignore the case, then I'll say true. So that is also possible. Now I'm saving it again and running it, and here you can see that it's only printing solid now, because that's the only state we have starting with S, and even you can see that it was starting with a capital S, but as we have ignore case set to true, we are getting this result. So that's how we pass functions as Lambda expressions in Kotlin. In this lecture, we'll be taking a look at how we can create functions and thus make use of reusable code in Kotlin. So in order to create a function, we need to use the keyword fun, F-U-N, and after that we need to give the name of the function. For instance, if I'm creating a function called sum, I'll be writing it sum, and here we need to pass some arguments. Now whatever arguments you're passing to a function, they all are immutable in nature. That is, by default they are treated as val, so you cannot update those values or change them. That's what immutable means. So here if I say x as double and y as double, and this function is going to return a double value, inside that I can simply say return x plus y. Now if I try doing this over here, x plus plus, this will throw an error because the variable x is immutable. So removing this, our function is now ready. In order to make use of this function, we can create a main function, and that will be array of string. Inside this, we can make use of the sum function by creating a variable result equal to sum, and inside that we will be passing some values, and once that's done, we can say the result is 30.5. that is sum of x and y is 30.5. Now here, a couple of interesting facts. First thing, you can even specify parameters along with their parameter name. So I can say x is equal to 10.5 and y is equal to 20.5. Now if I execute this, the result remains the same, but you get the idea that you can pass it using the named parameters as well. Now the benefit of using a named parameter is that you can reverse this order. So I can go ahead and say y equals 20.5 and x equals 10.0. Remember that in our sum function, x is the first parameter and y is the second parameter, but here we are passing y as the first and x as the second parameter. But as they are named parameters, the position doesn't matter. So we save this and run this again, and there you go, the result still remains the same and there's no confusion as such. Now we can also create functions with default values. So I can create a function, let's call it as arithmetic operation. So here you can see that I've created a function arithmetic, x and y remains double. We have introduced a third parameter as operator, and that is of type string, and we are providing a default value to it. You can see how we are providing a default value. So addition is the default operation that will be performed on these two, x and y, and the output is obviously a double value. And here we are just saying if the operator equals plus, then do plus. If operator equals minus, then return x minus y, else return minus 1. So if I have to use this now, I can go over here, say result is equal to arithmetic, and then I can print the result. So if I execute this now, result is minus 10.5. Now notice x is 10, 10 minus 20.5 is minus 10.5, and the operator is minus. Now if I remove this from here and then run this code, you will see that the output now comes as 30.5 because the default operator that we have is addition. So it will sum up these two values and it will print the result as 30.5. Now there's also a scenario where you have n number of operators, where you have n number of parameters of similar nature. So in order to take care of such scenarios, we have var argument, that is variable argument, a keyword. So using that keyword, we can actually create a function which will take n number of arguments as input. So here I've created a function called SumUpValues with var argument as the keyword with the parameter num, and if I have to make use of this, I can simply go ahead and use it in my main method. So here you can see I'm saying sum these values, that is 1, 2, 3, 4, and print its result. So if you see, the function SumUpValues is actually expecting only one argument, but as we have said that it's going to be a variable argument, we can easily specify n number of arguments of similar data type. Like over here we are passing integer. So if I run this now, we are getting the sum is 10, that is 4, 3, 2, 1 added all together will return 10. So that's all about functions in Kotlin. In this lecture, we'll be taking a look at how we can handle null values in Kotlin. So by default, Kotlin is a null safe language. By this, what I mean is whenever you're creating a variable, you must initialize it as well. For instance, if I try executing this piece of code, it will throw an error. There you go. It says variable foo must be initialized. So here, I must initialize it with some value. Now if I save this and execute, it will run properly and it will return the value of foo. So here we have some value. Now what if you are required to have a null value for this variable? Well, in that case, you need to append a question mark symbol next to the data type of the variable, and here you can go ahead and assign it a null value. Remember, you cannot assign a null value in this way because at this point of time it's not expecting a null, but when you append a question mark, it's all set for accepting null value. Let's save this and run it, and here you can see the values coming as null. Now if I have to print the length of this particular string, let's create a value len as integer, and then let's access the length of it. Now here, if I try doing this by printing the length over here, foo being a null variable, and here I'm trying to get the length of a null value. So here you can see it says only safe or null or non-null asserted calls are allowed. So what I need to do over here is, first of all, make this length variable a nullable int, which I will do by appending a question mark next to the data type, and then over here I'll add another question mark. So now if this is null, in that case it will return null as the length. Otherwise, whatever string it will have, it will count it and it will return that as length. So let's save this now and run it. So here you can see the second null is actually the output from the length. Now if I go ahead and say it is as some value, save it, and now run this, you can see that it is now counting the total number of characters that's there in the string, some value. So now this is all null safe. There's one more way of handling this condition, and that we can have it in this way. If length is not equal to null, in that case I can simply say length is $len, else length is null. Now this output will be assigned to this variable msg, or message in short, and I can print it over here. Let's save this and run it again. So here it says length is 9 because len was not null. Now if you want to handle exceptions for some cases, that also you can do by ensuring that your code is throwing an exception, and that you do by making use of null assertion. For instance, I can write a function over here, try, and let's write catch. We'll see what we need to handle over here. Now let's have a variable val null length of type integer, and here I'm saying if length is null, in that case it will throw an error, otherwise it will simply print the value is null length. Otherwise it will throw an exception of type Kotlin null pointer exception, and here we can simply say println, and this null length is null. Now let's save this, and here make sure that we are having len as null. So let's run this now, and there you have it. It has thrown the exception and the catch has actually caught it. So here we have the output null length is null. So that's how you take care of null values in Kotlin. In this lecture we'll take a look at how we can iterate through collection of data. In this example we'll be taking arrays and we'll be seeing how we can loop through the array items and print them. So here the first example is that we have created an array of integer using the array of method. We have already covered arrays, so you can go back to that lecture in order to understand how arrays are created. Here we will be covering how to iterate through collection of data. Now that we have an array called nums, the first way of iterating is using the for loop, and here you can see I'm making use of for number, which is a variable in nums. So basically the in operator is being used over here for number in nums, and then we are printing the number over here. So this will print 1 2 3 4. There we have it, 1 2 3 4. Now other way of printing or iterating through collection of data is by making use of indices method. So here let's say if I copy paste this, what I'll do is I'll say for, let's say I in, and this is the array that we have, nums dot indices. So here I'll be printing out nums of I. The best thing is that you don't have to increment the I variable over here. Kotlin does it automatically. So if I rerun this, you can see that it's printing the same thing twice, 1 2 3 4, and then again 1 2 3 4. So that's another way of iterating through. And one more way is you can also specify step to this one. So by default it's step 1, and I can say step 2. So in that case it will skip 1 and then print. So let's comment this one and run this to see the difference. You can see it's printing 1 then 3. So here 1, then step 2, so it's skipping this one, step 3, and then again skipping step 2. So that way only 2 items from this array are printed over here. One more way of iterating through collection of data is by making use of the size method. So here if I copy this and put it over here, let's uncomment this, and here I'll be saying I in 0 dot dot nums dot size minus 1. Now this way it will start from 0 and it will go to size minus 1, because size actually counts the total number of items in the array, and index position starts from 0. So that's the reason why we are subtracting 1 from it. So 0 to nums dot size minus 1. Here now if I print it, it will again print the same thing. There you go, 1 2 3 4. Now one more way of using size is using the until method. So here we are now saying, so it says for I in 0 until nums dot size. So until basically avoids you to write minus 1 over here. That way it goes from 0 to nums dot size minus 1 by default, and that way you can iterate through collection of data in Kotlin. previous lecture, we covered for loop and saw how we can iterate through collection of data. In this one, we'll be covering while and do while loop. Now, here the array remains the same, that is an integer array. And in order to make use of the while loop, we can see that we have a keyword called while, and then we pass a counter variable. Now, counter is initialized with 0, and we are running it less than nums.size. So total number of items in this array is 4 and index position 0, 1, 2, 3. So this will run counter less than 3. And here we are just using the getter method over here, and we are then passing the counter variable current value and printing it. So kind of accessing it via index, and then incrementing the value of counter by 1. So it will keep on looping through and printing the result of the array. Similarly, we have do while loop. Now the difference between while and do while is that in case of do while loop, the condition will be executed at least once. So here we have counter set to 0, and then we are printing the index value exactly same way how we are doing it in the while loop, and then incrementing the value of counter by 1, and finally checking it till it's less than nums.size. So that way we can iterate through collection of data using while and do while loop. Let's run this and see it in action. And there you have it. The output is 1, 2, 3, 4 from the while loop, and then 1, 2, 3, 4 from the do while loop. This lecture will be covering try and catch block. So whenever you are handling something which can raise an exception, for instance database connectivity or number conversion or variable assignments which can lead to null values, in such scenarios it's better to wrap your code inside try catch block. This allows for a graceful termination of your program. Over here you can see that we have created a variable called foo of string type, and we have initialized it with a null value, and later on we are assigning the length of that variable to len variable. Finally, we are trying to access the value of length and assigning it to null length. In case null length is actually null, because over here we are making use of the assertion operator, so if there is a null value, it will throw an exception of type Kotlin null pointer exception. In that case, we will be printing these two lines, that is, the variable null length is null, and whatever message Kotlin has for this exception, that will be displayed as well using e.message. So that way we can handle exceptions in Kotlin. There is one general exception block as well, so if you're not sure what exception type to mention, it's always better to go with the normal exception as this. So instead of Kotlin null pointer exception, you can just write this exception and that will follow along. Now let's go ahead and execute this program and see the output. Here you can see it's printing null length is null, which is the first line of this catch block, and then we have println e.message. Now the message over here as of now is null, and that's the reason why you see null as output. So in this short tutorial we learned how to make use of try catch block in Kotlin. In this lecture, we'll be taking a look at dynamic data collections. So this lecture will focus on lists, and then we'll be covering sets and maps. So here, lists can be of two types, mutable or immutable. Initially, we are starting with immutable types, and here you can see in order to create one, all we are doing is val then the name of the list, like shape list, using the method list of, and passing the values like square, rectangle, and triangle for shapes. Here you'll see 3 methods coming up. Now the first one simply prints it, and the next one is having toString method, which will be printing it as a CSV, comma separated value, and last one is actually printing the total number of items that are there in the shape list variable. So here the count will come as 3. Next we are creating mutable list. So here the variable name is shape lists, and we are making use of mutable list of method of type string. And then we can make use of the add method, using which we are adding pentagon and hexagon as shapes. Then we are making use of the sort method to sort it in ascending order, and then printing it out over here. No need of semicolon, so just removing that. The other method to sort in descending order is sorted descending, and then again we are printing the same. In case you want to remove any items from the mutable list, you can make use of the remove method and pass in the value itself, or you can make use of the remove at method and pass in the index position of that value. So let's go ahead and save this and run it now. So before running, there is a correction over here. The method is joined to string, and by default it takes a comma. So when we are running this, you can see that the first line prints the array, that is square, rectangle, triangle. The next line prints the comma separated values, square, rectangle, and triangle. By default this separator is taken as comma itself. The size is coming as 3. Now here you can see that we have added these 2 values, pentagon and hexagon, in this order, P and then H. We are sorting it and then printing it out over here, and then we are sorting it out in ascending order. So here the sorted list is now hexagon and pentagon, and once I comment this one and run this, the sorted descending is actually showing me pentagon and hexagon in that order. Finally, when we are making use of the remove method, I'm removing hexagon from that list, and when printing you can see that the only item remaining is pentagon. Finally, I'm removing that as well by specifying the index position 0, as pentagon was inserted first at index position 0. Once that's done, we are again printing it, and here you can see an empty list coming up. Now one more thing I would like to highlight over here, in case you are trying to create a mixed set of list which contains strings as well as numbers. In that case, if you try specifying over here like 15, this will be treated wrong. In order to make this work, you'll need to specify the data type of it as any. So here you'll say any, and then this will work. So let's run this now, and as you can see over here, it's now printing total items 4, and these are the items that we have. So that's how we work with lists in Kotlin. In this lecture, we'll be taking a look at how we can work with sets. So sets in Kotlin are exactly of 2 types, mutable and immutable. Over here, we are creating a mutable set of string. So square, rectangle, and triangle. These 3 are items in the set that we have. The difference between a list and set is that the order in which you are adding items to a set is not guaranteed. So even though it looks like the square over here is at index position 0, but when you will try accessing it, it won't be available. So the order over here is not guaranteed. Next thing that I would like to highlight over here is, in case you are having similar kind of data mentioned in the set, you can just get rid of the data type over here. So instead of this, we can go ahead and write val shift set and mutable set of. So this works as well. Now we can go ahead and print it out. Shift set, save it, and run it. And there you have it, square, rectangle, and triangle. Now one more thing about sets is that only unique values can be inserted in a given set. So here I'm trying to add pentagon as a shape in the shape set, and I'm removing rectangle from here and then printing out the shape set. Let's do that. So here you can see in the output it's now saying square, triangle and pentagon. Rectangle has been removed. But if you try to remove using the index position, then in this case it will not work. To take care of that, what you can do is you convert the shape back to list and then perform the index operation. For instance, I can create the shape set to shape list as to mutable list. So once I have it as a mutable list, I can go ahead and make use of the remove at method, and whatever item will be at this index position, it will be removed. So let's go ahead and take a look at it now by printing it. So I'll say print shape list. There we have it. Triangle and pentagon are now there in the list, and square has been removed. Now one more thing, in a list we can have a duplicate item. For instance, I can go here and say shape list dot add a triangle. So now let's again print this thing out. You can see triangle, pentagon and triangle that are there in the list. But if you want to convert it back to a shape, which you can do using the toMutableSet method. So here I am getting a new shape set, and let's print this over here as new shape set. So shape list is now converted to a set, and when we'll be printing it out, you'll notice that triangle comes only once. So here you can see only two items are there in the set when we are converting it to a mutable set, that is triangle and pentagon. So that's what I was mentioning earlier, that only unique values will be there in a set. So that's all about sets in Kotlin. In this lecture we'll be taking a look at maps, how we can create mutable and immutable maps. So the first thing that we are doing over here is creating an immutable map. To create an immutable map, we are making use of the map_of method, and here you can see for each item in the map we have a key value pair. So here we have key as 1, then the value rectangle, 2 value triangle, and 3 value square. So that makes a key value pair, and these are the contents of the shape map. We're then printing it out over here. Now next we are creating a mutable map, and here you can see we are specifically mentioning that the key and value will be of type string. Here it has automatically inferred that the key is of integer type and value is of numeric type. Now here you can see we are having letters depicting the key and then the words for the shape. So R is for rectangle, T is for triangle, S is for square, and here we are printing it out. Now these loops that you see are basically iterating through these map collection. So here you can see in old Java convention what we are trying to do is for shape in shape maps.keys, and we are printing it out over here. Shape is for shape maps.get, and then we are passing the key over here to get the value associated with that key. And here the other iteration that we have, here we are passing both the things together, so shape and value in shape maps. So we have removed the key from this syntax, and you can see that how readable this one is compared to the earlier version. So here we are saying shape is for and then the value. So if I now run this, a couple of things that you'll notice over here. First is print ln shape map, so that is printing over here rectangle, triangle and square. Then we are printing shape maps. This is also having the similar set of values. So here you can see R for rectangle, T for triangle, S for square, and then these two loops that are executed. So the first one says R is for rectangle, T is for triangle, S is for square. Then the last one says the same, but in a very readable way. R is for rectangle, T is for triangle, S is for square. So that's how you basically play with maps in Kotlin. Now that we have covered the basics of Kotlin, it's time now to cover the basics of Android application. So in our earlier lectures, we have already created one sample application. Now here we will be exploring some of the important files that the application provides. One such file is called Android manifest.xml. Now this file is actually helpful in knowing what all activities are there in an application. For instance, over here you can see that this application has got one activity known as main activity. In other words, you can think of the manifest like a directory that lists every component that is used in the application. Here you can see the application tag, and just inside the application tag we have the activity. So every application consists of one or more than one activity, and in each activity we have got intent filters. Now this specifies that this is of the action main and the category launcher. So here we have got action as main and category as launcher. So in short, it means that we want Android to list the main activity in the launcher. So when we'll be coming up in the next lecture, where we'll be creating this application and running it on device or emulator, you'll get the icon of the application, and clicking on that will actually launch this, and you'll see the main activity screen content over there. And this is all done by the manifest. Next we'll be exploring the other units of the application, like activity layouts. So that and all will be coming up in the next lecture. In the previous lecture, we explored Android manifest.xml file. Now in this one, we'll be taking a look at activity. The easiest way to go to any activity is by clicking Control and left click. If you are using Mac operating system, then you can use Command plus click to go to that particular activity. Here you'll notice the extension of this activity as mainActivity.kt, which means it is written in Kotlin. Now if you want to see the hierarchy of this particular activity, where exactly the file is located, you can go ahead and select this icon over here which says scroll from source. Click that and you will be taken to that particular file. So here its hierarchy is app, Java, then the namespace, so for application, com, SkillBakery demo, Kotlin, Android demo, and then we have main activity. Now this activity comprises of one method which is known as onCreate method, and this onCreate method is actually setting the content view to this layout that we have, which is activity main layout. In the next lecture, we'll be taking a look at how to access this layout. In this lecture, we'll take a look at how we can access the layout files. So here in main activity, whatever layout you want to access, just click on that and press Control and left click. If you're on Mac, you can press Command and left click to open up the activity over here, layout activity. So here you can see there are two modes. First is the design mode that opens by default, then we have a text mode as well. So you can see the same thing either in design mode and use these tools to create your layout, or you can go ahead in the text view where you'll see the XML format notation where you are able to create components like text view. So here you'll notice that this is the basic or parent node, which is of type constraint layout, and inside this we have a text view. Now the text view displays this text that we have over here on line number 12, that is Android text hello world. Now you will notice that this particular activity main.xml file, when we were accessing it from the main activity, was following this convention, which is r.layout.activity main. Now R actually stands for resource, and then we have layout and then the name of the activity. So here if I go and click on this icon, it will give me the path of that file, which is res layout activity main.xml, and R that we were referring over here actually stands for resource, and here the same directory is called res. So res layout activity main.xml. In future, whatever layouts you're creating, if you're keeping them inside this layout directory, you will be able to access them using the same notation like r.layout.your activity name. Now in the next lecture we'll see from where all these strings can be managed. This lecture will be taking a look at how we can manage string resources in one single file. To demonstrate you that, I would like to go inside Android manifest.xml file, and here you'll notice this label, Android label, which says Kotlin Android demo. But if you'll closely look at it, it's being highlighted with a background color as well. Now if you just double click on this one, it will actually convert to the actual notation, which says @string /app_name. Now where exactly this string is, if it's not here. If you click on this by pressing Ctrl and left click, you'll be taken to strings.xml file. Again click on this icon to go to that particular file. So here you can see it's inside resource values strings.xml. Now the reason why we should keep such constants at one single place is because if you are trying to go with multi-language feature for your application, you'll follow the same naming convention, whereas you'll have a directory which will say values dash and then the shortcode for that language. For instance, for French it will be fr, so values dash fr, and inside that if you'll have a strings.xml file, Android will automatically pick up that strings.xml file if your language of the device is French. So it automatically does that if you just follow the convention, and for that reason we should be keeping our constants in one place. So here you can see the name, app name is Kotlin Android demo, and that is what it was displaying over here. And if you have to access a string, you just prefix it with @string /app_name. Now in the next lecture we'll take a look at how we can work with images. In this lecture we'll be taking a look at how icons or images are actually accessed in our application. Over here I have opened Android manifest.xml file, and here you'll notice Android icon. Now this icon is having this variable saying mipmap and then IC launcher. If I press Ctrl and left click, then you'll see a couple of icons coming up over here with the same name but having a different folder convention, which says mipmap HDPI, MDPI, XHDPI and XXHDPI for the XXX HDPI. Now DPI stands for density, so basically we have mobiles with various resolutions, and based on that Android automatically picks up the best image for that kind of density. So here we have HDPI, which means high density, then MDPI, medium density, extra high definition or extra high density, and then we have XX and XXX HDPI. So if you want to access any of these images, all you need to do is just click on them and it will open up over here. Now again click on this icon and it will take you to that specific image. You'll open another image and you can compare both of them, MDPI, XXHDPI. So here you'll obviously notice the difference in resolution, and depending on the kind of density your device supports, Android automatically downloads that file. So that's how we have images managed in Android application. In the next lecture, we'll take a look at how we can work with styles in our application. In order to work with Kotlin, we must have JDK installed. Here you can see that I've provided two links. The first one is for JDK version 9 and the other one is for JDK 8. I'll be installing Java Development Kit 8 on my system, and here clicking on these links will take you to these pages respectively. So 9, this is the page you need to download based on your operating system. There you can see that for Windows it has provided 64-bit version, and similarly you have different file options for Linux, macOS and Solaris. So you can download either JDK 9, but I would recommend going with JDK 8 as it's available for 32 as well as 64-bit operating systems. So here you can accept the terms and conditions and accordingly choose whatever version you want to download. For instance, I can go ahead and choose this 32-bit version and click on this to download the program. Once downloaded, you can just click on this executable to begin the installation process and follow the instruction along the way. So once it's downloaded, you can click on this to begin the installation process. Now you click on yes, and here you can click on next. Then let the default setting be there, and you can see that it's going to install at this location C program files x86, which represents 32-bit libraries directory, and then Java JDK 1.8.0 underscore 161. You can change it as well, but I would recommend to keep this directory as is. Then click on next, and as you can see, it will install the JDK, and here you are provided with another option of changing the destination folder. If you want to install it in this directory, let it be and click on next. And here you can see it says installing Java. Soon your Java Development Kit will be installed on your system, and then you'll be all set to work with Kotlin using your favorite IDEs. And that's pretty much it. You have successfully installed JDK on your system. Click on close now. So in the next lecture we'll be installing IntelliJ, as well as we'll see how we can include support for Kotlin in Visual Studio Code editor as well. Now in this lecture we'll be starting with creating a new Android application using Kotlin, and this application will actually fetch some images from Flickr API. So Flickr, as you can see, is a REST based API, and it has got well documentation over here. Currently you are seeing the flickr.photos.search method, and it contains a lot of arguments, but most of them are optional. For instance, if I want to do a search on keyword called nature, I will specify that in this value over here, text value, and based on that it will return me some results, as you can see over here. So these are all photo collections that we have, and as you can see it is showing me total of 100 records per page, and the total result that it has is around 44,825. So all in all 44,825 pictures of nature are available. So we'll be using this API. Now in order to make use of the API, you will first of all require to create an application, and Flickr actually provides you application of two kinds. It's commercial or non-commercial. So obviously I'll be going for a non-commercial key. Click on this one, follow the steps, and then you'll be provided with a set of API keys, that is private key, which is a secret key, and then a public one. So using that, you'll be able to make REST calls, which obviously I will be showing you in upcoming lectures. But here's how you can create your own app and get the API keys. So once you have that API key, you can go back to this page and explore this method, flickr.photos.search. It allows you to output the result data in a couple of formats like XML, JSON-P, JSON, as well as PHP. And this is just sign call with no user token. So if you want to explore this first and then go back and test out with your application, you can make use of this parameter or this option, sign call with no user token, and it will give you the list of results over here. That way you will be able to ensure the results are there for that particular keyword, and you'll be able to check it further when you will be integrating this in your application. So in upcoming lectures, we'll be starting with this one. I'll be creating one app. Just now I showed you, so you can also follow along. In this lecture, we'll see how we can make use of a new plugin introduced by JetBrains to convert JSON objects to Kotlin classes. So over here, we are on the plugins page of JetBrains. You can see it, plugins.jetbrains.com, and this is the name of the plugin, JSON to Kotlin class. Now you can go through the list of features that it has, but in general what it does is it will create classes based on the JSON data that you will be passing in. And here it has got two variations to it. First one is creating separate class files, and the other one is creating internal files. So all you need to do over here is go to the download section and here download the latest version. Once you have downloaded it, you'll get a zip file. Now you'll need to open your Android Studio, and here you'll need to go to File, then go to Settings, and there you'll need to find the Plugins option. Once you are there, just click on Install Plugin from Disk. So here you'll need to go to that directory where you have downloaded that file and then choose the zip file, for instance this one, and click on OK, and then you need to restart the Android Studio. Once you do that, you can just select the directory where you want to create the files and press Alt Insert. You'll get this option, Kotlin data class file from JSON. So here you will be providing the main class name and then the JSON text. For instance, I can just copy this whole output, and here in the JSON text I can paste it, click on format to format the same, and then give it a name. So based on this data, it will create classes, what all classes are required, the dependent ones as well. So that and all we'll be seeing in the next lecture. In the previous lecture, we saw how we can make use of the APIs provided by Flickr in order to search some photographs. Now here we'll be focusing on the response that we have received. So here you can see we are getting a collection of photos in this over here, and then we have all these result sets which are having ID, owner, secret, server, farm, and title, and finally is public, is friend, is family. So these are the attributes provided for each of the photographs. Now Flickr has a unique way of generating the URL. So here you do not see any URL for those images. So what we will be required to do is we'll be required to frame the URL from these attributes. So here on the other page you can see how the URL is configured. So we have farm ID, we have server ID, and then we have photo ID. So all these combined, including the secret, forms the URL, which you can see over here on top. So here we have farm, then farm ID, staticflickr.com, then server ID, then the photo ID and secret, and then the extension. If there's no extension, you just need to specify JPG. You can also specify the sizes. So here we have M for medium, S for small, T for thumbnail, and Z for medium, then B for large. And if you specify it as O, then it will be original size, what the user uploaded. Okay, so that's how we will be framing the URL. Now, next thing that we need to do is create our image application, and inside that we'll have to create a model class which will basically map these attributes, so that when we receive this information in our application, we can convert them to that particular class and then use it in our application. So we'll be starting by creating an application. I've given it a name called image app, as you can see over here. And next, inside the app directory, go to Java, and here I've created a package. In order to create a package, all you need to do is select the parent directory, click on add new, and here you will find package. Just click on that, give the name, like I've given it as models. And now we'll be making use of the just installed plugin JSON to Kotlin class. In order to do that, we'll be selecting this models directory. You'll notice that when you're going to code menu, you'll have this option generate, and here's the shortcut for it, Alt plus insert. It might be disabled for some cases, but you can always select the directory and press Alt insert to open it up, and there you need to select this Kotlin data class file from JSON. Here I'll be giving it a name called Flickr, and then I'll be pasting the response that we received from the search API. I'll be removing some just to make it short and sweet. Then click on format, and it will just make it more readable. Finally, you need to go to settings, and here just leave the default options, then go to other. Here you have the option of enabling inner class model. In that case, it will generate one file, and within that one file all classes will be generated, and I would recommend leaving it unchecked. And here, once you are done, all you need to do is click on make. As soon as you do that, you will be presented with these files: Flickr, photo, and photos. So here you'll notice that it has got this photos, then we have photo. Okay, so based on this data structure, it will generate a file which you can explore over here. So if I open Flickr class, you'll notice it has got photos, which is of type photos. Now if I open photos, you'll notice it has got page, pages, per page, total, and photo. Photo is list photo, which has been created over here, which contains ID, owner, secret, server, farm, title, is public, is friend, is family. What I've done further is added this serializable attribute, because we will be requiring it as a class of our own when we will be making use of the Retrofit API. So I have added this serializable attribute to it, and this is the namespace which you need to import. So that's done now, and if I just take you back to this, you'll notice all these attributes, ID, owner, secret, server, are part of the photo class. And when you are exploring photos, you will notice page, pages, per page, and total. So here you've got that, and at the end, if you see, we have stat as OK. So that's why the Flickr API that we have on top has got these two values, photos and stat. And photos, as mentioned, contains these attributes and photo. So you can see how easy it is to actually create classes using this new plugin. Otherwise, it becomes very tedious to understand the class structure, how that will be created, and that at times is the most time-consuming part. And this has been taken care now by the new plugin that we have installed. So our model is set now. We'll be working on the API in the next lecture. In this lecture, we'll be exploring Retrofit, how we can include it in our project, and how we can make use of Retrofit to actually consume Flickr API. So the first thing that we need to do is ensure that we have internet permission So we'll copy this from here and we will go to our Android project. Here, just above the application tag, we will be including this. Once that is done, our next step will be to include some dependencies. So here, as it's mentioning, we will need to go to our app build.gradle file, and there we will have to include these 3 dependencies. So let's copy this, and here in our Gradle script app, you can see we have some dependencies mentioned. We'll include retrofit over here, and then we'll require to sync this. So let's go ahead and click sync now, and this is going to download the dependencies for retrofit and include it in our project. And once the sync is successful, you can see the message over here which says synced successfully. So we have now included it in our project, and in the next lecture we'll see how we can create APIs using which we'll be actually consuming the Flickr REST services. So we have seen in the previous lecture that how we can make use of retrofit library to make REST API calls. Now in this one we'll be creating 2 classes which are needed to get photos from our Flickr website. So as mentioned earlier, we'll be using the REST based APIs provided by Flickr in order to get some images matching a particular search request. So here the first thing that we'll be doing in our image app is creating an API folder. Folder basically means package, so here I'll select package and I'll click over here, say API, click on OK. Inside this directory or package, I'll be creating a new interface. So I'll go and I'll say Kotlin file class, and here instead of file I'll say interface, and then I'll be naming it as photo API. Clicking on OK now. Now why we're creating an interface? It's because retrofit uses interfaces for creating the REST services. Now inside this interface we'll be having a function. So let me do that as well. So the function that we'll be creating is get photos, and here you can see we are making use of the call API which is coming from retrofit2.call. So we have imported that, and then we're passing the Flickr class that we just now created. So Flickr comes from this image app models.flickr, and we have it over here inside models directory. Now once we have this with us, we either have to do asynchronous or synchronous operation in order to get the results, and retrofit supports both. So here what we'll be doing is we'll be adding an annotation which will be a get annotation, and it will contain the set of parameters that we are supposed to pass. So as you can see over here, it is requiring a reference. Let's press Alt Enter, and here just select import. It will be imported as retrofit2.http.get. Now the method is Flickr photo search, and this is the API key. Text is nature, format is JSON, and here it is no JSON callback. So this one will return a JSON object. Now over here we'll be creating another file, and this time it will be a class. So right click on it, click new Kotlin file class, and here choose class, and then give it a name as photo retriever. And as mentioned, we'll be having a service variable over here. So as you can see, we haven't initialized it, and that's the reason why this is throwing an error over here. But that's not an issue as of now. We'll be definitely doing it or initializing it later. Now over here we'll be calling another method called initialization method. Now this initialization method, as you can see, we are making use of the retrofit builder, so we'll be including that over here. Then we are converting the response from JSON to Java. So for that we need JSON converter factory. So basically we are now having this URL, REST URL, and we'll be querying it on this URL, that is the base URL, and then the API that we have over here, get method, that will be called. So this plus this value together will form a URL get the results, and then we'll be showing it to the user by converting whatever response in JSON we have received to Java object or Kotlin basically. So here we have our service object now. Now using this service object, we'll be basically calling the getPhotos method. So here I'll be creating another function, getPhotos, and this will have a parameter callback of type callback Flickr. Internally, this is going to make use of the service that we just now created, and using this service we'll be calling the getPhotos method that we have in our photo API. So getPhotos API will be used, and as mentioned earlier that Retrofit provides both types of calls, that is asynchronous and synchronous. Over here we are making use of asynchronous call by making use of the enqueue method, which we can do by calling call.enqueue and then passing the callback. So once it calls this method, basically we are sending a request to Flickr API, and whatever response will be there, that will be gathered, and in the upcoming lectures we'll see how we can make use of this getPhotos API to get those results and then process it, show it as a UI in our image application. Now that we have created our API and models, it's time now to put them to test. So before actually going and designing the UI for this image application, I thought of testing out the API code that we have written. So over here what I've done is I have declared a variable called photos, which is of type photos, and initialized it as a null variable. Next, what I've done is I have created a method called photoRetriever, and this is coming from here, photoRetriever. So I've created an object of this, and after that I've used the getPhotos method. So here you can see we have the getPhotos method, and it is expecting a callback of type Flickr. So here I've passed the callback, and you can see that the callback has been initialized as Flickr, and inside that it has got two methods, onFailure and onResponse. As we were using enqueue method to call it asynchronously, that's why we have these two over here, onFailure and onResponse. So if everything goes properly without any error, in that case onResponse will be called, and here we'll have the response from the server in form of response Flickr. So as you can see, we are checking it out. If the response is successful, in that case we are assigning photos to this variable that we have created over here, photos. So this main activity.photos will hold all the data that is being returned from Flickr API. So now I'll be running this. So I've connected this one with my mobile, and as we will be running it in debug mode, we'll be selecting this, and I have set some breakpoints. So here you can see that I have selected the response at the breakpoint, and you can see the body of it, so response.body, and that is going to contain photos, and that is what we are assigning to the photos variable. If you closely look at photos, it has got two things: a collection of photo object, and then certain attributes like page, pages, per page, total. And here you can see stat as well, but stat is something which we are not looking at as of now. So in the upcoming lectures, what we'll be doing is we'll be retrieving all the photo collection that we have received over here, and for each one of them we'll be preparing the Flickr API URL using which we will be able to view the images for each of these results. So I think there are 100 of it that is coming over here in this collection. So per page 100 records, and that's what we get. So initial 100 images will be shown in our application. So we can see that it's working pretty fine now, and in the next lecture we'll be starting with designing the UI of the image application. Now in the previous lecture we saw how to make use of the REST API, Flickr API, in our main activity. Now what we need to do is list out all the images. So to display images in our application, we'll be making use of Android's RecyclerView widget, and then we'll be requiring to create an adapter for it. So in this one we'll be creating the adapter layout. So here you need to go on res and then go to layout, right click, select new, and then select layout resource file. Clicking on that, it will prompt for file name, and there you need to mention the photo underscore item. Click on OK now. So here, if I take you to the photos model, you'll notice that it has got this title thing and then a couple of other fields which combine together to form a URL. So here in our photo item, I'll go to the text view, and I'll be just updating this one with and there you can see that we have a photo item which will be used to display the image, and then we have a title as a text view. So that text view will come on top of the image view. So you will have image in the background and then a title on top of it. So that's how the app will look, as you can see over here. So in the next lecture we'll be taking a look at how to create an adapter for this. In this lecture we'll be creating the adapter. In order to do that, just select the project directory, right click and select new, and then go to Kotlin file class. Here you need to enter the name of it. Let's call it as main adapter, and then over here select class, click on OK, and you have your adapter class created now. Next, what we need to do is, in the adapters constructor, we want to pass in the list of photos and click listener. So for that we'll be adding these two over here, photos and click listener, and here we need to specify the package names. So I'll say import, and then this photos that we have over here, and next here we will be including this as well. Alt enter, and there we have both the things now. Next, we want our adapter to subclass RecyclerView adapter. So here we'll add a colon, and then we'll add RecyclerView.adapter. So here we'll be doing RecyclerView.adapter. In order to include this, we'll again press Alt Enter, click on import, and that is, there we have it now. And this photo holder that we have currently does not exist. So to do that, we'll be creating a class. So select this, create class photo holder, and it will be inside the main adapter class itself. So here we'll be adding inner class photo holder. Now once that's done, we'll then have some constructor variables passed over here, like the item view. So here we'll be doing that of type view, and this again we'll be having from RecyclerView.view holder. So RecyclerView.view holder, and in that we'll pass the item view. There we go. Now inside this we'll have two things. First is the title, so we'll say var title, and this will be of type text view. Next we have photo item, and here this will be of type image view. Now you can see that all these are coming as red underlined. So the reason why, because we haven't initialized this, and this we need to do in our initialization routine. So here we have our initialization routine, and inside that we are setting our click listener. Here we'll have item view.tag is equal to this, and then title as title and photo item. So these two that you see over here are coming from our layout that we created over here, photo item.xml. Okay, so now our initialization routine is complete. As you can see that these red underlines have gone now. So here, in short, this finds all the fields and sets a click listener on the view if one was provided. Now here you go to main adapter, put your cursor over there and press Alt Enter. Here you need to select implement methods and select all of these. Okay, so we have on create view holder, get item count, and on bind view. Select all and say OK. So now we have the function implementation over here. We need to write all these functions on our own now. So we'll be starting with get item count. Here in our get item count method, we'll be returning the total number of photos. So we'll say return photo.size. So we'll remove this one and we'll say return photos.size. Next we'll go to on create view holder, and here we'll remove the default implementation, and then we'll be making use of return photo holder with layout inflator. So here we'll have this included, and we'll be passing the context from the parent that we have in our view holder, and here you can see we're passing photo item and then the parent. Okay, next method that we need to implement is on bind view holder. So on bind view holder, inside this method we'll be creating a variable called photo. So here we'll be removing this. We'll be creating a variable called photo, and it will pick the photo from the position that it is having, and next we'll be retrieving or assigning the values to holder. So holder, and it could be null, so we'll have a question mark dot title is equal to, we'll say photo dot title, and here we'll have to assign this thing to the text property of the title, because this is text view, and then we are saying text view dot text equals photo dot title. Next, what we need to do, as we have this syntax with us for Flickr images, we are preparing one over here as val URL, and then we are using the form ID, server ID, photo ID, and secret to create this URL. We are then making use of the glide feature, which you can install from this com.pumptech.glide.glide, and this has been mentioned in our build.gradle file. As you can see over here, compile pumptech glide 3.7.0. so that gets included over here, and using this, what we are saying is we get the context and then load this URL into this photo item. So basically this image will be shown to this photo item image view. Finally, we'll be adding a function to get a specific photo, and this will be actually used in our main activity. We'll call it get photo, and here's how it's gonna look. So you can see that we are passing the position and we're returning photo. So here we say return photos and then the adapter position. So we've just finished creating the RecyclerView adapter that can load and display images. In the next lecture, we'll take a look at how we can show these photos now. This lecture will be actually implementing the full functionality that we have created till now. So here I'm inside activity main.xml, and here I'll be removing this content main thing and the floating action bar button. Let's remove this, and over here I'll be including the RecyclerView, so it will look like this, and here I've given it a name called RecyclerView, which we will be actually using in our main activity. So on the main activity, we've already seen how we are fetching the REST APIs using the Flickr URL, and we are assigning it to the photos collection. Now next, what we need to do is create a couple of more variables for adapter and RecyclerView. So here I'll be putting it in this way. We have main adapter of type main adapter, and then there's one more way of creating variables using late and it, which means you can initialize it later. So here we have RecyclerView. I'll be importing it now, And once that's done, I can include or initialize this one in the onCreate method. So inside the onCreate method, I'll be accessing this just below the set support action bar, and here using find by ID we'll be getting this RecyclerView. Next we'll be assigning a layout manager to this RecyclerView, and that will be of linear layout manager. Now once that is done, we are actually receiving the response that is inside the onResponse method. We'll be actually calling the main adapter and populating it with the result. So here we'll be saying main adapter photos.photo and then this activity. Now click listener as of now has not been implemented. We'll be doing that as well, and then we will be assigning this main adapter to our RecyclerView. So here we'll say RecyclerView.adapter as main adapter. Now in order to implement the click event listener, we need to enhance this main activity. So just after app activity, we need to specify the view on click listener, and you can see that now it's showing error over here. So we'll say go on this main activity and press Alt Enter and say implement members. So here there's just one, so we'll say OK, and it will have it over here on click. Let's call it as view. Let the default implementation remain here, because as of now we are not writing anything over here. We'll be creating another activity which will be showing the details of that particular image, so that will come later. We can move this at the bottom over here, like this, and now you can see this at main activity is not throwing any error as such. So once everything is done, if I run this application now and show it to you, you'll notice this is how the application is currently looking. The images are there and the title is coming on top of it, and if you scroll it, you'll see other images being loaded up and presented to you. So that's how we create our wallpaper application. In the next lecture we'll see how we need to handle the on-click event and create our detailed view as well. This lecture will be creating our detail activity, and in order to do that we will be just clicking on this folder and say new, then go to activity, and here we'll say empty activity. We'll give it a name, detail activity, and then the source language going to be Kotlin. Click on finish. Under resources layout, you'll see a file called activity_detail.xml, and here I'll rename it to detail activity. Click on refactor, and there you go. So we have detail activity over here and respective activity detail.xml file. The sync is going on, and once that is complete, we'll proceed with our detail activity. So now the syncing is successful. What we need to do in our manifest, go to Android manifest.xml, and here you can see the detail activity is included. We'll include a theme, that is app theme, no action bar, what we have over here. Close this. So we are done with the Android manifest. Now we'll go to activity detail.xml file. So we'll be removing this, and here we'll be having one of our own. So we have included one image view, and here we need to specify the context as well, which is nothing but the namespace. So I'll be writing it as com.skillbakery, dot demo dot image app dot detail activity. So our activity detail XML is complete now. You can have a look at the design view as well. So this is how it's going to look. Now I'll be going to detail activity, and here we'll be accessing the image view that we have just now defined in our activity main.xml. We'll also be accessing the photo object that when clicked from the main activity will be accessible over here. So this photo that we have, we will be actually creating a companion object. So companion object in Kotlin is a way of creating constants and statics. So here we are actually putting photo as a constant, and that is what we are using over here in getSerializable. Let's include that over here. Next we go to our main adapter. On here you can see that we have our URL defined, using which we were populating the image over there. The same thing we need to do here as well. So let's paste it over here, include this, and here we have the URL as form server ID secret. All these variables are required over here. So the reason why it is showing error, because we have to make it nullable. Now in order to show the original image, we will also have to add one constant over here, and that will be O, which stands for original. And here instead of holder we will be actually passing the current context itself. So removing everything else, we are loading the URL now into the image view that we have created over here. And we'll be putting this inside a block where we will say photo dot, let's say, form dot let, and this will go inside this. Finally we'll have our image view dot set on click listener, and we'll say finish over here. Apart from that, we'll also be including the toolbar over here, and we'll have our set support action bar as toolbar. So that is it as far as our detail activity is concerned. Now let's go to our main activity, and there we'll have to write our click listener. So here in our main activity, this is the function which we need to update. So I'll be removing this, and that is pretty much it. We are calling the intent detail activity, and here we are passing main adapter dot photo holder to our holder, and then we are calling the extra, which actually passes data from one activity to other. So this is the constant that we defined, and this is the adapter get photo holder dot adapter position. Using that we will be accessing the photo for a particular position, and that photo details will be passed to detail activity. So let's save this and execute it now. So there are two things that we need to take care of first before running this. One is we need to specify B for large images, not O, and the other thing is this toolbar namespace that we have over here, that's android.support.v7.widget.toolbar. So these two ones included and compiled, we'll be able to launch our application, as you can see over here. So here we have all the images, and if I click any one of it, you'll notice that it will load the image in large size. So that was our detail activity for the image.